Hello, everyone. Today we are going to start 9.5. So I'm thinking of covering that in 2 sessions. So today we'll do some parts of it. So transition matrices and recurrence relation. I thought to show you with the on the book, like how it's in the textbook. It's a bit easier for this one. So I will still post these slides on the Google Classrooms for your notes and examples, but I will explain you from here. So as you know, we have done transition matrices last time, how to draw them and how to make a diagram and how to make the matrices out of it. So today we are going to do the recurrence relation. So why we are using it? Because it helps us in predicting, so making some predictions. So the power of transition matrices is that they can be used to make predictions. So you can use them to predict something. So for example, in the situation where we have looked at last time, if you remember that matrix, like 70, so what does that mean? It means that 75% of shoppers at Eastworld 1 week will shop at Eastworld next week. So because it's E on both sides, right? And then 25% or 0.25 of the shoppers, they are just gonna, who are doing shopping at Eastworld, are gonna do the shopping at Highton next week. So if you remember, we have done that last week. So what happens if we have to make some predictions out of this? So just assume if this week 23,000 shoppers go to Eastworld and 12,000 go to the Highton. So it means we have got a new matrix now with 23,000 for, because E is first. So we are putting for Eastworld first here. So 23,000, and then for Highton, it's 12,000 here. So if we multiply that one with our transition matrix, because we know it's 75% are going, and then 25%, and then 10%, 90%. So if we times these two matrices together and we get an answer, so we can see that 18,450 shoppers are predicted to go to Eastworld next week. And 16,550 will go to Highton next week. So just by multiplying these two, we can get the answer. So we can make some predictions. So now, like that is the data. Maybe we already know the starting data and we have to predict, okay, what will happen after 3 weeks or 4 weeks or 2 weeks. So there we use the recurrence relation. So if we have to predict how many shoppers will go to each center the week after that, like after next week, after that, so what we can do, so now we got a new matrix here, we can just multiply this one now with our transition matrix. So this new matrix for the next week, we times that with the transition matrix to get the answer for the week after. So we can keep on doing that. Similarly, if you want to know that for the 3rd week from now, how many shoppers will go there? So we will still do this new one with the transition matrix and we'll get the answer. So that is a kind of recurrence relation. So we call our initial values, which are given here in the question, as initial state matrix. So this 23,000 and 12,000, which was given at the beginning, we call that as S0. So S0 is known as initial state matrix. And then the next one is the S1. So next week and the week after and so on. So that's important thing to note here. So then the recurrence relation that we will be using, that would be S0, that is your initial state matrix, which was this one in this case, and sorry, this one, and then Sn plus 1. So to find the prediction for the next week, what we do, we times the transition matrix, which was T, this one's a transition matrix, by the value of the this week. So that's your Sn. So you need to remember that it's transition times whatever your current matrix is. Okay, so remember that, it's really important. Note it down for your notes. Okay, so now we can use a CAS calculator for trial and error or to use this recursive computation. Okay, so I'll just do the same question in this one. So what we need to do. So this week, 23,000 shoppers went to Eastworld and 12,000 to Highton. Use the recursive computation function on your CAS to find how many shoppers go to each shopping center after 4 weeks. So if you keep on doing that by hand, that gets like a really big, so, and time consuming. So we use CAS, of course. So what do you need to do? So I'll show you that a bit on CAS. So I'll try to put it here so that I can see the values. Okay, so you go to your calculator page on your CAS, and then you need to enter the first matrix, like the initial state matrix. So the values given to us are, so that is a transition T, and then S0, what would that be? 23,000 and 12,000. So we just need to enter that here. So this one. So 23,000 and 12,000. Okay, so now you need to store this matrix because this is our initial state matrix, that's S0. So you need to store, you need to go control, store as S0 and enter. So now this value would be stored as initial state matrix. So now the next step, yes, you need to times it with the transition matrix. So you need to enter that matrix here. So again, you write that one. So it was, I think, 0.75, 0.1, 0.25, and 0.9. Okay, so now this matrix, store, control, and here store it as T and enter. So now these two are stored. So now you know for the initial, like what will happen after next week. So like not after, sorry, next week. So you need to times it with, so if you, I'll show you here. Yeah, so you can just write it here now, T times your S0, and you can store it as, you can, so you need to store that one, T times S0 as S1, because that is your for the next week, and enter, so you get the answer here. So now you keep on doing that because that is for after week 1, and we need to find after week 4. So you keep on doing that. So you just write, instead of writing those matrices again, you can just write T times S1 this time, and then you can store it as your S2 and enter. See, so you're getting the answer straight away instead of typing it again and again. Then you do the same thing, T times S2, and then store it as S3 and enter. The same thing again, because we need to find after 4. So T times S3, and then store it as S4 and enter. So that is the value. So that's your answer. So that many shoppers will go to Eastwood after 4 weeks, and that many will go to Highton. So it's pretty easy. All the step-by-step instructions are given in your book. So we just rounded it off, 1, 2, 3. So you can see the same answer we have got here. Okay. So that is a rule. So it means after n transition, we are just keep on doing T times, like we can also do, instead of doing, if maybe they're just asking you after 4 weeks, what if they are asking you after 12 weeks? So it gets a bit really big and lengthy if you keep on doing this way. So there is another way of doing it. So instead of doing this, you can just use that one. So you can store your both of the transition and initial state matrix, and you can just change the power here. If it's 4, you can put raised to the power 4 and you get the answer. So maybe if we do here, T raised to the power 4 times S0. So we still get the same answer. See? So instead of doing that 4 times, you can just do raised to the power and times your initial matrix. That's pretty much it. Yeah, so make sure you note that as well. So the example related to that is now, so a fleet of trucks starts each day at one of the 2 depots, A and B. By the end of the day, the truck ends up at either of the 2 depots according to the following transition matrix. So that is a matrix given to you. So what you need to find, they have already given you the initial state matrix. That's a 40 trucks at depot A and 100 at B. So, and also given you the transition state matrix. So what you need to do, how many trucks are at each depot after 6 days? So you can just use the same formula. So you know the initial state matrix is 40 and 100 and N is 6. So just use the formula this time. So enter in the CAS. If it's only once, you just don't need to store the variables. You can just enter the matrix in the CAS raised to the power 6 times your initial state matrix and you get the answer here. And similarly, after 10 days, you just raise to the power 10 and you get the answer. Okay, so I'll stop here for today and we'll do this long-term trends next time on Monday. And we'll finish chapter 9 on Wednesday. And on Friday, we'll do a bit of revision. So it means next Monday, we'll be doing our SNN task for chapter 9. I'll give you more information about that soon. So for today, do prep 1 and 2 and the exam practice questions which you can are related to the concepts we have covered. Hope that makes sense. All right, bye.